Okay, so welcome everyone to this second episode of the winter edition of the AI Spotlight seminar series, which is organized by the Italian Association for Artificial Intelligence and the AISB, the Society for the Study of Artificial Intelligence and Simulation Behavior, represented by the president, Bertie Müller. Today is a great pleasure to have here as a speaker Bernardo Magnini. Bernardo is a senior researcher at the Fondazione Bruno Kressler in Trento, where he is responsible of the NLP research group. His interests are in the area of computational linguistics, in particular in lexical semantics and lexical resources, question answering, textual entailment, and conversational agents. He has published a number of very impactful papers. He has also co-chaired several events, including the Evalita campaign, the first CLIC conference, the first Italian conference on computational linguistics, the Hyperia 2018 conference that was in Trento, and ACL 2022, the 60th annual meeting of the Association for Computational Linguistics. And he has been contract professor at the University of Trento, Bolzano, and Pavia, and has been the president of the Italian Association for Computational Linguistics from 2015 to 2022. So today he will talk about large language models, not unsurprisingly, which is a huge topic today in AI, and in particular about the topic of rethinking the evaluation of this kind of model. So without further ado, welcome Bernardo, and the stage is yours.
Okay, thank you very much, Antonio, for the nice introduction, and good afternoon to everyone. So the topic of this seminar is about NLP evaluation, and particularly how we do evaluate large language models today. So this is the overview of the seminar. I will start with a bit of context in NLP evaluation, going across traditional machine learning approaches, then a few words about what I call the BERT period. BERT was the one of the first large language model available, and then what we are doing today with large language models. I will. My goal is to highlight a few issues which make peculiar the evaluation of large language models. One of these aspects is prompting. You know that we interact with large language models through prompts, and here one of the issues is that LLMs are very sensitive to different prompts, which calls for a strategy called multiple prompting. I will talk about how we can compose multiple prompts, starting from simple prompts, and we'll talk about metrics for multiple prompt scenarios. A second topic is about the kind of tasks that we want to evaluate. Basically, there are two kinds of such a task: classification tasks and open-ended tasks. Classifications means that the answer to the task belongs to a predefined set of labels, while open-ended means that there is no this set of predefined answers. And the two tasks have different properties, and they behave differently in large language models. I will talk about two possible formulations for the classification task: multiple choice and generation. I will bring some numbers, some results about evaluating large language models for the Italian language. This is an activity that I carried on in the last 6 months, more or less. And then I will conclude saying that having a fair, objective evaluation of large language model is still a research challenge. There are still open issues that we need to address. Finally, I will talk a bit, just presenting pointers to a couple of recent initiatives on Italian. Okay, so a bit of context first on NLP evaluation. We talk about large language models. We know about them. They are systems trained to predict the probability of the next word. So this is how they do work. They predict the next word given the context, given a certain context. We call large language model generative models because they produce actually new textual content. And what is important for our purposes is that large language models are supposed to simulate a variety of linguistic skills of a speaker of a language, including conversation, question answering. They can give advices, making summaries, writing a text, translating from one language to another, giving explanations, and so on. So this rich variety of tasks make them very interesting from the point of view of evaluation. So probably this is the first time in the long history of computational linguistics where we can actually test many different tasks, language abilities, language competencies, using tools which are very good in, at least, or reasonably good in their capacities. So why evaluation is important? Because this is a fundamental approach for boosting technological progress. So the goal of evaluation is to compare, in this case, large language models with different characteristics. So we want to know whether one certain LLM is better or worse than another. It allows to improve existing large language models if you are able to point to specific weakness of a model, for instance. In addition, evaluation can orient research directions. If a new task, a new metric is developed, is proposed, then this may become the subject for a research field. This is how the NLP field has been working in the last 30 years. We used to have several so-called evaluation campaigns or shared tasks organized by sort of competitions. So, for instance, we still have cross-language evaluation forum, CLAY. We have Semeval, we have Cornell, we have Evalita in Italy, we have national evaluation campaigns for many languages in Europe. Virtually, I could say that most of the research in NLP in the last 30 years was around participating, organizing, sharing evaluation data in several campaigns. There is an additional advantage of evaluation, which is testing new applications. This might be also interesting for companies. There are three main ingredients in NLP evaluation. First, we want to define a task, the input, the output of a certain task. We need data, a data set. Usually data are split in validation, development, train, and test data. All of them with annotations, typically human annotations on a certain task. And finally, the third ingredient is metric. So we need to score the system, so basically to compare a metric able to compare the output of the system with the human with a human reference. The starting point here is about traditional machine learning. So as an example, support vector machines. Starting from the beginning of 2000 to 2015, traditional machine learning approaches has been used in NLP. Here, the point of interest for that is that the model didn't have any prior knowledge. This might be strange if we see today the knowledge of large language models, but at that time, 10 years ago, our algorithms, support vector machines, or also conditional random fields, were able to learn starting from zero knowledge. And part of the work for the developer of such systems was feature engineering. This was meant basically to find relevant information which could help the learning algorithm to generalize with respect to the data. Usually there was a vector of features for each data point in the data set. And also, differently from today, we were testing, developing, evaluating one task at a time. A major step in evaluation and NLP technology happened in around 2018 when BERT was delivered. BERT is bidirectional encoder representation from transformers. Was basically the first neural architecture based on transformers. Transformers are today the core of large language models. This kind of language model changed a lot the evaluation approaches. So basically, using BERT, there is no need of feature engineering, simply because the contextual embedding automatically built by BERT demonstrated to be very good features for a number of NLP tasks. So Still, there was a strong distinction between what the model BERT was able to do, producing good contextual embeddings, and the prediction phase, which was not in charge of BERT, but rather was in charge of a classifier, a logistic regression classifier, for instance, trained on annotated data using so the training data using the BERT embedding as features. So in this approach, a new classifier was necessary for every new task at hand. Then another step happened. It's recent, in the last, starting from beginning of 2023. Let's say after ChatGPT came out in November 2022. So now we have large language model pre-trained and also instruction tuned. So as an example, I mentioned the Llama family, open source large language models. Using this kind of large language models, we can fine-tune a large language model, a pre-trained large language model, using training annotated data. During the fine-tuning on a specific downstream task, some or a part of the parameters of the large language models are updated. This way, the model changes, and typically the model forgets the capacity on different tasks. So fine-tuning means optimizing the parameter on a specific task, let's say sentiment analysis, but losing the capacity to generalize over other tasks. For this kind of large language models, it is necessary to interact with the model with the prompts. So prompt engineering started to be an active area of research, also for evaluation, as we will see during the seminar. It is important to notice that at that time, so 2 years ago, 3 years ago, a lot of annotated data for evaluation was available through the evaluation campaigns I mentioned. I could say that probably thousands of data sets are available, but virtually none of those data sets have been thought to interact with a large language model. So basically, they do not have any prompt. Okay, so they are raw data without any prompt. So this is the reason, because those data need to be adapted to the LLM interactive style, prompt style. So for instance, talking about sentiment analysis, we might have a tweet annotated as positive, but then this is not enough for interacting with a large language model. We need a prompt, so we need something like which is the sentiment of tweet, and we need to give some instruction about the task, the possible answers like positive and negative. And finally, recently, as we have very large language models with good language capacities and better instructions, we can use large language model in a zero or a few shot modality, so that there is virtually no need for training data, or just a few. This is a kind of revolution in this area, as we can actually obtain reasonable performance with few training data. Another very important difference with the past is that for those models, the parameters are kept frozen. Basically, the model does not change, which means that a multitude of downstream tasks can be executed with the same model. Again, prompt engineering is fundamental here. Even in the few shot, even more in the few shot approach, and we can, as those models are generative models. One of the issue is that they output language, they output text, which in many cases needs to be parsed in order to understand whether the output is correct or wrong with respect to a certain task. So, preliminary discussion after this short excursus on NLP and evaluation. There are two relevant aspects which characterize large language model evaluation. As far as the input is concerned, we need prompts. Okay, this is, we cannot interact, we cannot evaluate, we cannot ask anything to a large language model without prompting. And so there are questions here arising like, do different prompts affect performance on a certain task? Can we find an optimal prompt for a certain large language model? This discussion, I will try to address these issues under the label single prompt versus multiple prompts. And the second aspect is about the output. LLMs always generate language because they have been trained to predict the next word. They cannot do anything else, basically. So one of the questions is whether we can condition the output of the large language model to a specific format and to a specific content. Here I will address this issue under the label generation versus multiple choices task. So I start with the single prompt versus multiple prompts. So as we know, LLM outputs probability distribution over the vocabulary of the model. So given a prompt like I have a dream of being the model predicts the next word through a probability distribution. This is the core mechanism, and we cannot change it. Okay, so for every kind of evaluation, every kind of task, we need to cope with this specific output. One issue which has been highlighted in several papers, recent papers, like this one 1 year ago, is that LLMs, and in particular small and medium models, are very sensitive to prompt variations, even very superficial prompt variations, something that for a human would be negligible. For a large language model is still very important, affecting significantly the performance. As an example, in this picture on the left, you see two variants of the same prompt, like passage, semicolon, text, answer, semicolon. Then, for some reason, the passage and answer are capitalized in the second variant, and we don't have the semicolon. And you see that this minor change produces a strong impact in the performance of the model, moving from close to zero to very high performance. So this issue is very important, basically. So at this point, different models, both the same model can be affected by different prompts, but also different models react differently for given the same prompt. You understand that for evaluation, this is a big issue. It is, of course, this example is about superficial orthographical variations of prompt, but here we see in another recent paper, the authors pointed out that paraphrases also affect in a significant way the performance of different models. Here we have 4 different paraphrases for the same task, different reformulations, which for a human are basically are considered as synonyms, so same meaning. This is not the case for a large language model, and you see, for instance, that different models, here we have 4 models, react completely different, okay? So the prompt P1 is good for the first large language model, the blue one, but very poor for large language model number 4, the violet one, okay? In addition, it is very difficult to predict the reason for those different reactions on a prompt. In this paper, the authors point out that there could be some interaction between the base model, the pre-trained model, without any instruction, and the instructed model. This is reasonable, but indeed, when we get a large language model, we get both the base and the instructed together. So it's really difficult to understand why there are such variations. So this issue about prompt sensitivity is very important. One thing that I do believe is that prompt sensitivity can be mitigated adopting a multiple prompt approach. So multiple prompt actually means instead of a single prompt, which may bring biases for one model or for another, we want to build, we want to test the performance of a model against a certain number of prompts. So here it comes the issue: how do we define such prompts? So I want to start with a few general practical rules. So these are very generic rules, okay, general rules, which apply to potentially all prompts. First, do not mix languages, let's say English and Italian, but use one language only. Some of the LLMs have been instructed to react for a certain role. So, for instance, you are an assistant, things like that. After several attempts, several experiments, I think it's basically better, it's preferable not to use such roles in a prompt. Minimality. I think it's a good practice to use as simple as and as short as possible prompt. It means minimally verbose prompts can reduce potential biases for a certain model. And then one thing which has been shown to be very useful is that if you know about the task, you know, for instance, that you want to classify tweets or that you want to provide a summary given a book, then it's a good idea to specify the type of the input text in the prompt. So these are general rules. In addition to them, I think that composing prompts starting from basic elements, it's a good strategy. So here I show you few of those basic elements. So the core question, which is kind of mandatory in a prompt, for instance, which is the sentiment of tweet. You can reformulate in alternative, you can reformulate the question as a statement. The following tweet expresses a sentiment. About the role I already said, and I think this has to be avoided. Task description, this is important. For instance, this is a sentiment analysis task. And then essential, even if it is optional, is providing potential answers, like A is positive, B is negative, C neutral, D is mixed. This is an example of composition. We compose the task description plus the question plus the answers. And the result is, this is a sentiment analysis task, which is the sentiment of tweet X, and then you say A positive, B negative, and so on, and then there is the last line, answer, semicolon, and then the model has to provide the one of the four answers in which has been listed. Okay, so this is a methodology for composing prompts. Using this methodology, and now I'm talking about work on Evalita large language model benchmark. We defined 6 different prompts: the question alone, the question plus task description, the question plus the answer, question, answer, and task description, the statement alone, statement plus task description. And these are 6 potential 6 prompts which we used with a few adaptation to 6 different tasks. So this is just to give you an idea of what does it mean multiple prompts, how they are defined. Of course, when we use multiple prompts, we also need metrics to consider results of different prompts. So there's been a recent paper proposing 3 metrics. So the maximum performance prompt, the prompt which obtain the highest performance on a certain task with respect to a set of prompts, the average performance of a prompt, so the average of the performance of each of the prompt in our pool, and then a combined score, which combines the maximum performance and the average performance. Basically, we apply this idea to a number of tasks in Italian. So, as I mentioned, we have 6 prompts which have been run against 6 different large language models. Here they are anonymized, but they are all open source large language models in the range between 7 and 9 billion parameters. What is interesting is to notice how each prompt behave. So if you look at the box on the right, the gray box, here you can see that one prompt, let's say number 4, achieved the best results, okay, as an average on all the large language models, but a different prompt was the maximum, achieved the maximum. Okay, so prompts is not prompts. Each prompt brings its own aspects, features, so that you don't know exactly in advance which prompt is the best one. You need to run all of them. So this is these are results on sentiment analysis. The numbers represent F1 macro, so one of the evaluation metric, and the configuration is 0 shot. Okay, now I would like to move a bit about classification versus open-ended tasks. Yeah, this is important. So given a task, usually the task is either a classification task or an open-ended. In a classification task, the answers are known and belong to a predefined set. In open-ended, like summarization or open question answering, you cannot, you don't have any of such predefined answers. It is important that any classification task can be formulated both as a multiple choice and as a generative task. We will know a bit more in a moment. While open-ended tasks can be formulated only as generative tasks. Classification task. This is an example taken from one data set for visual question answering. It's called the POPE. Here we have two possible formulations of the task. So suppose you have a question like, are there broccoli in the picture? In the multiple choice formulation, we list two possible answers, yes and no. And then we run the large language model. The large language model will output a probability distribution over its vocabulary, and basically we look in this probability distribution for the answer, for the word, for the token predicted, which maximize the probability, the log probability of the answer, yes or no, given the prompt, are there broccoli in the picture? Basically, what is practically done is to append one of the answer to the prompt, calculate the probability, then append the other answer, no, to the prompt, calculate the probability, and select the highest probability, the answer which produces the highest probability. So the model generates, but then in this formulation, multiple choice, you directly go to calculate the probability for each of the potential of the options of the answers. In the generative formulation, the question is the same. Are there broccoli in the pictures? Then you need to add the kind of answer you expect. Answer either yes or no. At this point, the model is free to conclude to generate, and the model could generate, for instance, yes, they are in the bowl, or there are two broccoli in the picture. Then you have to parse the output of the large language model to find one of the two possible answers, yes or no. In this case, yes will be found in the first answer. Yes, they are in the ball. There is no either yes or no in the second answer, which is considered wrong. Okay, so same task, classification task, you know in advance the label, multiple choice and generative formulation. It's interesting to confront the two options, multiple choice and generation. So, for instance, in sentiment analysis, you have a prompt, and we run both the multiple choice and the generative formulation with the two open source models, Gemma and Velvet, for Italian. You see that Gemma basically obtained the same result with the multiple choice 70.7 as in the generative formulation. So does not change anything basically for Gemma, while for Velvet obtained better results in the generative formulation. This is quite interesting, okay? Usually you expect the way around, better the multiple choice formulation. Open-ended task, here the answer does not belong to the set of predefined labels. So for instance, in summarization, you cannot define any predefined set for a summary. Only the generative formulation is possible. So you run a prompt like you have to solve a task of automatic summarization, summarize the following text, and then provide the summary. And the summary, the output of the large language model is evaluated through a comparison with a human reference, with a summary produced or more summaries produced by human. There are several metrics like Rouge, BERT score, B-laser, and so on, which basically do not capture very well the idea that if a summary is well done or not. A possible alternative is LLM as a judge. So using a powerful LLM to judge whether the summary is good or not. We can also confront classification with open-ended tasks. Okay, this is an experiment we run in the context of a visual question answering benchmark for Italian called Maya. Here we have the same question, okay, addressed both as a classification, caption foil. You have to, the model has to choose either the caption or the foil, and as open-ended, judged with LLM as a judge. So in this case, you see that this model, QN 2.5, produced basically in the open-ended loses more than 20 points of accuracy, meaning that answering open-ended is still more difficult for a model. Here I would have some numbers, but I don't know how much time I have. I mean, the goal here was to show some interesting results on evaluating Italian models. This is QN 2.5, the best model out of 20 models that we experimented. Everything is zero shot, and we have 6 classification tasks in blue, 4 generation tasks. And the results are a bit below expectation. So the average for these 10 tasks, the average performance is 42. Okay, so that's not so high as we could expect. Okay, so this is zero shot, but there is there is quite a lot of room for improvement. The best prompt obtains kind of 16 points more with respect to the average of the prompt. So this is an indication that the multiple prompting strategy actually is important, is effective. The open-ended tasks like lexical substitution, summarization, named entity recognition, relation extraction, they are significantly worse than the classification task. This was expected. One of the issues is that the output for those tasks is really an issue for the model. The few shot is always better, but in one single case, lexical substitution. So few shot is very useful. The execution time for the 10 tasks, about 25K data points on a single GPU, H100, takes kind of 7 hours. So that's it's a bit impressive. Okay, let me go to the conclusion. So first, my intuition is that a fair and objective evaluation of LLMs is still quite challenging. There are several dimensions to be considered: input, output, single prompt, multiple prompts, zero shot, few shot, generative, multiple choices. So a lot of variables to be considered. And in the context of a very fast evolving technology. Something which was not completely clear to me was the computational cost of evaluation. Potentially, this is very expensive. I mentioned the hours of GPUs, state-of-art GPUs for a single task, for a single model. There is a kind of general issue, which is that we know that probably, likely, several data sets that we use has been already used as pre-training for the large language models. This opened the risk of high contamination between the large language model and the evaluation. Not clear how to address this issue. And finally, I would like to mention a few recent progresses on Italian. There are two initiatives which I mentioned already. One is Evalita LLM, a reference benchmark for Italian. We have 10 native Italian tasks, both multiple choice and generative, with multi-prompt. And the second is Maya, a benchmark for visual question answering, videos on Italian, kind of 20,000 caption foil pairs and 2,400 open-ended questions. There are recent papers for each of them. And I would like to give credits to thank Roberto Zanoli and the whole Evalita large language model team, including people at iGenius and at the University of Turin, and Giovanni Bonetta, Davide Testa, the Maya team, which includes also people at the University of Trento, CNR in Pisa, and University of Pisa for the Maya initiative. Thanks a lot for your attention.
Okay, so thank you, Bernardo. Thank you very much for the talk. I don't know if you can see us. Yeah, okay, we can.
Yes.
Yeah, do like that. So I will start with some questions, and then we will wait to see whether there are other questions. So you mentioned that in this kind in this evaluation phase, it is useful to have these multiple strategies. For example, you mentioned the multi prompting strategy and so on and so forth. But at the beginning of the talk, you also mentioned the importance of preparing the data for this kind of interactive task. So one question that came to my mind is the following. So what about, for example, trying to include also this multi-prompt strategy also within the data set? So to mention at least a schema of this possible multi-prompt within the data of the data set themselves. I don't know if this is, let's say, something you were...
No. This is of course interesting. So our approach is to include prompts in the task. So basically, there are data and task.
Mhm.
The task defines prompts and the prompts and the metric to be used for evaluation. So the data, for several reasons, have been left kind of untouched. So because they can be reused for other purposes, with different prompts, for instance. We didn't want to impose on the data our methodology, our prompts. So other people can do it differently. Okay. So anyway, we published everything on. I didn't tell about that, but we use an open source library which is called LLM Eval Harness, available on Hugging Face. All our data are published on Hugging Face together with the tasks. So basically, you can look at the data and look how the task is defined over the data.
Okay, that's clear. Thank you. We have another question from the YouTube chat by Edgar Castillo that asks, what do you think trying to build prompts for evaluating prompts? So this is...
Okay, this is also a kind of meta question. This is useful for LLM as a judge. So when you use a large language model like GPT-4 or for evaluating the output of a certain model and comparing the output of the model with a human reference, usually, you have to define prompts for evaluation, exactly what this person asked for. I'm not so I did this several times, but maybe it could be an interesting research direction to be more having a more well-defined practices for evaluating prompts. That's a good suggestion.
Okay, I don't know if there are other questions. I don't know, Giuseppe. I don't know if he wants to jump in or... Yeah.
Hi Bernardo, fantastic talk. Very, very nice.
Too generous.
For me, coming from VR, LLMs are really providing some sort of fulfillment of what Joe McCarthy used to call common sense, right? So the fact that you could instruct a program, but then have some sort of background common sense that for many years we thought common sense was a theory of everything. But instead, maybe LLMs are the right answer to it, right? So it's not a theory, a consistent logical theory of everything. Is knowing enough to say something, to give the right alphabet, to give the right tools, okay, then some maybe reasoner, maybe external reasoner can use in order to draw conclusions. However, when you do that, now they are still very imprecise in returning this sort of pseudo model. For example, if you try to say, given a description of a room, give me the PDDL, okay, in planning, no, the PDDL description, okay, so that I make the room actionable. So I wonder if you have been thinking about how you actually prompt somehow a little bit like in early in software engineering when you do early requirement, or how you prompt this common sense so that it gets enough information that you can start working with it from a logical point of view.
Okay, a difficult question, of course. So maybe what I am interested in this period, at least, is to evaluate the degree of consistency, of coherence of large language models when they are prompted with similar questions, similar but they provide different answers. So I think this is so. In terms of evaluation, this means building a benchmark of tests able to detect the degree of coherence of a model. So the more the model is coherent in its answers, where coherence is the logical coherence, so something that we impose in a certain way. So the more such coherence, the more we are able to measure in a quantitative way how much the model is coherent. I think the more we get closer to answering your question, basically. So I see, at least for me, for my personal research, I think I would like to build benchmarks able to test the coherence of a model. For instance, same question, but in different modalities. Classification, like caption foil, and open-ended, okay? So as a human, I could do this task very easily, okay? I could provide the same answer both in the caption foil modality and in the open-ended modality, which is not true. It's not the case for large language models. So, and I would like to define metrics, aggregate measures for consistency. This is still not there, okay? We have independent tasks with each with its metric, its own metric, but I think it would be much more interesting having aggregate metrics able to capture the coherence of a model.
Okay, thank you. We have another question from the chat by Giovanni De Gasperis that asks, what is your opinion about distilling reasoning models with LLM runtime test instead of fine-tuning, like, for example, with DeepSeek R1 or OpenThinker?
Yeah, I think that the direction is exactly zero shot. So, I mean, if you are a company and you want a kind of, let's say, information extraction system from medical documents, probably the best option is still fine-tuning, okay? But then you are able to get, let's say, 5-10 points more on using fine-tuning than the zero shot or few shot. But the future is about few shot. So I think that distilling knowledge and yeah, we see that the proprietary models are evolving very fast in this direction. So everything about RAG, retrieval augmented generation, improves performance. So that's the good direction, I think.
Okay, thank you. We have one last question by Veronica Tarasova that wrote in the chat and asked about often, as you mentioned, for the same prompt, an LLM might give different answers. So how many times should we ask and record the answer to have a stable, let's say, version of the answer? So
that's a very good question. So this is exactly what we do not know in this moment. We don't know how many prompts are enough for a certain task, for a certain model. We don't know which is the optimal. So my suggestion is to develop methodologies, best practice. This is the only way to progress, I think, in this direction. But I'm afraid there is no an answer to this good question.
Okay, so I think we can stop here. Thank you again, Bernardo, for this great talk and this great Q&A. We had a lot of discussion. And yes, so for all of you, see you next month. We will have another episode of this winter series of seminars with Alessio Lomuscio from Imperial College. So bye everyone, and see you.
Thank you very much to everybody. Ciao.